Good evening, everyone. My name is Kevin Lagore from Focus Astronomy, and this is the Grand Canyon Virtual Star Party for 2020. Now, unfortunately, due to current events, we're not able to attend the beautiful night skies of Grand Canyon, but we're going to try to do our best by providing this virtual star party where we capture amazing images through our telescope and stream them onto the internet for all to see. So, before we get started actually viewing objects through the telescope, we want to get acquainted with what's up in the nighttime sky and how to explore the nighttime sky. And we can do that through understanding constellations. And the best way to go about that is to actually take a look at what's up in the nighttime sky. So, constellations I like to think of a lot like states, and the bright stars in them are the cities, and the little faint fuzzies that we actually want to go see are the cool off the beaten path things we want to see in our road trip. So this time of year that Grand Canyon normally takes place is moving towards the end of spring and into the summer. And at that time there are several popular constellations that we can actually see. First one, of course, is Leo the Lion, which we can see right here. Leo is easily distinguished because it looks like a backwards question mark. So you have the head right here, and then going down to Regulus, which is the heart of the lion. And it can be seen as the backwards question mark, followed by a box and the tail, and that is Leo the Lion. This is really easy to see this time of year, even from most backyards. But if you have the ability to head off to dark skies, this constellation is easily visible just after dark. Just a little bit north of that location, of course, we have Ursa Major, which most of us are more familiar with as the Big Dipper, which we can see right here. Let me turn this off real quick. Right here, this would be the Big Dipper. But the full constellation is known as Ursa Major, the large bear, essentially. Ursa Major houses a lot of different galaxies, and it also gives us the ability to find the North Star. And the way that's done is we find the Ark and the Dipper here, and the lower portion, and you find these two stars. You have Merak and Dubhe, and those point, following those point right to Polaris, the North Star, in which everything in the night sky pivots around. Now, if we were to actually go through the night and fast forward through this, the stars, as we can see, actually rise in the east, setting in the west, and everything pivots right around that central hub, which would be Polaris or the North Star. Now, let's rewind real quick and get back to the current time. There we go. So when we're up in Grand Canyon, one of the major things of getting out to a dark sky like that is seeing the Milky Way. And normally this time of year, just after sunset, we can catch the Milky Way rising as kind of a faint bar of light in the east. And as the night progresses, that gets higher and higher, becoming more distinguished. Now, some of the major constellations in this region would be Scorpio the Scorpion, which can be seen right here. Now, what I really like personally about Scorpio is not only is it a scorpion in some folklores, but it's also a fish hook if you head out to the Hawaiian Islands or some of the island locations in the South Pacific. This is actually Maui's fish hook, in which Maui fished all the islands out of the sea, and then they placed the fish hook in the night sky. Moving over from that, we have Sagittarius. And Sagittarius is very interesting because it resembles a teapot. You can see the spout, bottom of the teapot, the handle, and the lid. And when you're out in a nice dark sky like Grand Canyon, the Milky Way core actually sits right between Scorpio and Sagittarius, and it actually looks like steam rising from the teapot and crossing the sky. So that's a very cool thing to actually see as well. Another major constellation that we have is a Cygnus the Swan, which is the very tip of that is Albireo, which is a double star, which will probably be captured in one of these virtual star parties throughout the week. Cygnus, starting with Albireo, comes down the neck, following the wings of them, and then following Deneb as the tail star. And what's cool about Deneb is it's actually part of a larger collection of stars called the Summer Triangle, which is made up of Vega, Deneb, and Altair. And if you ever get the chance to get out to Grand Canyon or to a dark sky location, you can hold your whole hand up to the nighttime sky and it will fit inside of the Summer Triangle. Kind of a cool observation and something cool to check out. The last constellation I want to talk about before we make our way to the telescope is Hercules the Hero, because we're going to be working inside of Hercules as well. Hercules can be found by identifying the 4 body stars. Looks a lot like this. This is what we call the keystone. And then we have the arms and then the legs down here. And that is the constellation of Hercules the Hero. Now, what's fun about constellations is that there is actually 88 of them in total when we're talking about the northern and southern hemisphere. 88 constellations, which is actually the same amount of keys on a keyboard or piano. But the main constellations that we're going to be working in tonight are going to be Leo, Virgo, Coma Berenices, Ursa Major, and then we'll dip down and almost straight up overhead to Hercules. So we'll be working in a lot of those constellations this evening as we pull images off the telescope. So we're going to get started, and the first target that we're going to be checking out is actually in Leo. Let me show you roughly where this is. It's going to be a galaxy. This is known as NGC 3643, and you can see Leo the Lion right here, and Virgo up here. It's just between and below, but it is technically part of Leo the Lion, right down in here. So let's flip over to the telescope. I'm going to hide our planetarium software for now and get things opened up here real quick. And the telescope, for any of the technical people that we've got here tonight, we're running a 6-inch refractor, and that has a special CCD camera. We're using a black and white camera or a monochrome camera this evening. And the reason we do that is because a monochrome camera is much more sensitive than a color camera. So throughout tonight's virtual star party, everything that we're going to be seeing is black and white, but the advantage of that is it's going to give us a lot of detail for some of the targets that we're going to be looking at. So let's get started in observing our target this evening. So I'm going to select our filter here. The telescope that we're running tonight, because it's a black and white camera, we have special filters on board to isolate different wavelengths of light. There's actually 7 of them in a wheel. We call that a filter wheel. And as you can see right here, let me move myself over so you guys can see. As you can see right here, these are all of our filters that we're using. And we can rotate any one of those. So right now we're going to rotate the green filter. Now the image isn't going to look green. The camera and the filter are actually isolating what would be green light, because that's what's sensitive to the human eye. And I like to use this filter because it resembles very similar what you might see in a telescope when viewing from Grand Canyon. So we're going to get this started. We're going to hit start. Now when we're doing astrophotography, unlike other types of photography, when you take a picture and it goes click, like with your phone, it's real quick. We're taking what's called long exposures. So the camera is open for an extended period of time, and that collects light of those faint, distant objects. And that's exactly what we're doing tonight. But another aspect of astrophotography is we're not only taking pictures, but we're stacking multiple pictures together, making a final image. And what that does is it actually smooths out the detail. And rather than us taking this crazy long, faint exposure, we're actually able to get a bunch of shorter ones, which can aid in tracking and making sure our image is nice and sharp for the final image. All right, so we're actually on our first target right now, and I know it doesn't look like there's a lot in the view. So this is the Galaxy NGC, or New General Catalog. That's what NGC stands for, 3643. This is in the constellation of Leo the Lion, and it sits at a distance of 84 million light years away. Now, if you're not familiar with what a light year is the distance that light travels in the course of a year, which is roughly 6 trillion miles. That comes out to about 186,000 miles per second. And so the galaxy that we're looking at is 84 million light years away. Now, take that number, 84 million light years. 84 million times 6 trillion, and that would be your distance in miles. So we actually use light years in astronomy as kind of the yardstick. It just makes it a lot easier to count at that point. So let's take a look. The galaxy is actually rather small, and the reason that we're actually observing the galaxy is not even for the galaxy itself, but I'll tell you a little bit about it. So we're looking right here, and let me get my little square up here so you guys know where we are actually looking. So this little fuzz right here is actually the galaxy, NGC 3648. That light left there 84 million years ago, before some of the dinosaurs that we're even aware of existed, is how long ago this light left. The galaxy is actually 23,000 light years in diameter. So going the speed of light, 186,000 miles per second, it would take you 84 million years to get there and 23,000 years to cross the galaxy. Now, from professional observatories, they've actually studied this galaxy quite a bit, and they've actually found that it's receding or moving away from us at about 1,000 miles per second. But what's interesting about this is not the little fuzz that we see right there. It's actually this little star-looking object, and it used to be a star. This is a supernova, and a supernova is a large star, much larger than our sun, that has died. And when a star gets much larger than our sun, when it ends its life, it doesn't just puff out and fade away. It explodes in a massive explosion called a supernova. And this particular type of supernova is called a type 1A supernova. And this occurs when a white dwarf or a smaller star pulls matter from a nearby companion star until it exceeds the Chandrasekhar limit. And that might sound a little technical, and it is. That limit is basically where the limitations of the star can no longer support gravity pushing in on it. So in stars, they are doing nuclear fusion, and it's pushing the material of the star outward. However, eventually you're going to get to a point where that loses and gravity is going to want to push in. So the outward force of a star is in a constant struggle against gravity pulling in. And eventually a star is going to lose. And with this particular star, that's exactly what happened. It reached this limit, and the mass and energy could no longer push out effectively, so it collapses and moves inward very, very quickly. And when that material hits the core, it basically ricochets back out really violently and very, very quickly, causing what's called a supernova. Now, there's multiple types of supernova, and this one is the type 1A, which occurs with two stars and one pulling matter from another. And this is the brightest type of supernova of all of them. Now, the interesting thing about supernovas is you can see how faint this galaxy actually is. There's not much to it. But with most supernovas, what tends to happen is that there's so much energy and it's so bright because of this sudden burst of energy that it outshines the galaxy that it's in for several days to several weeks. And this one was discovered April 21st, so we're talking several weeks that have already passed since its discovery, and it's still visible even in amateur telescopes. This is only a 6-inch telescope from urban skies, and it can easily pick up this galaxy and this supernova. So again, this is NGC 3643 in the constellation of Leo. That's 84 million light years away and 23,000 light years in diameter. All right, so we're going to stop our exposure real quick, and I did want to show you real quick before we stop. What's cool about a lot of this is when you're taking pictures of some of these objects, and let me get my little square out of the way for you to clean this up. You'll notice this is what we're looking at, but if you look close, there's a fuzz there, there's a fuzzy there. They're all over the place when you look, and these are actually galaxies. There are so many galaxies out there that when we're taking these detailed pictures of the nighttime sky, it's not uncommon to catch other objects in the frame, as well as viewing through a telescope. If you go out to Grand Canyon or join us out there in the future, and you're looking through the telescope, it's not uncommon that if you look in there, there might be some other objects in the view as well. So let's close this up real quick. We're going to head over to another target. This one's kind of fun. Let's get over there really quickly. Get this, see if we can get this lined up for us real quick. So what you see here, this is the software called SkyX. This is actually controlling all of our telescopes, and then we can get our images off of there as well. So let's see if we're on the target that we want. And we're going to start the exposure here real quick and see if it starts to pull up the detail that we're actually looking for. That's not what we're looking for. It's close, but it's not what we're looking for. Bear with me just a second, and we will get right onto the target that we are talking about real quick, which should be right here. So let me slew the telescope over there real quick. Just a little hop. There we go. And we'll get back over onto our camera real quick. Now, this next target is actually kind of fun, and you can actually do this in, a 6-inch telescope. You don't need fancy cameras to see this object, and it's a fun one to do with friends and family. And this particular one, of course, is called the Stargate Star Cluster. And let me pop up our little square here just so I can show you guys what we're talking about right there in the middle. You're going to notice a triangle of stars, and within it, an inverted triangle of stars. And this is in the constellation of Corvus the Crow. And I can pull that up real quick, and we're looking right over here. This is Corvus the Crow, and this is Stargate right there. So it's on the northern portion of Corvus, not far from the popular galaxy M104 or the Sombrero Galaxy. So let me fade this out real quick. As you can see right here, it's composed of 6 stars. And what's interesting about this particular cluster is while it looks like they're all coherent, they're all together, they're actually not. The stars in this particular object range from 285 light years to 486 light years. So there's a good chance that they actually in reality have nothing to do with each other. It just has some perspective from here on Earth that we're actually able to see this. And like I said, if you want to do this visually with your eye, you can do this in about a 6-inch telescope. The larger telescopes will help resolve some of the finer, smaller stars, but it's something fun that you can try out with friends and family, and it's relatively easy to see this time of year as we transition from spring and eventually moving into the summer. It's in the southern part of the sky, like I said, in the constellation of Corvus. And this is called the Stargate star cluster. So that's kind of a fun, exciting little target to go ahead and try viewing on your own if you ever want to get a chance. Or if you ever join us at Grand Canyon, I guarantee there'll be a telescope that'll be on this object. It's just something different. It is an asterism, just like the Big Dipper, which is basically just a little made-up fun object in the nighttime sky, and it's not quite to the level of a constellation, so we give it the title asterism is the name of that. And this is the Stargate star cluster located in the constellation of Corvus, ranging in distance from 285 light years to 486 light years. And let me pull this up one more time. We're looking right here. Let me pull out the square real quick so you can see the star chart. Here's the constellation of Corvus. We're looking right now in the southwest, and it's just above Corvus on the very northern region of the constellation of Corvus, the Crow. So that's it for that cluster. We're going to move on once again to another set of galaxies. We're going to stop our camera real quick, get back over to the telescope controls, and pop on over to our next target. And this is actually a 2-for-1 deal with this one. So let me get the telescope right on over there. And while it's doing that, let me show you roughly where in the sky this actually is. And this is in the constellation of Coma Berenices. So let me show you where that is. So Coma Berenices, there's not a lot to this constellation. Kind of looks like an L. It's just north of Virgo and Leo, right up in here. And there's a bunch of galaxies in this region. And that is where we're actually looking at. And this is going to be NGC 4302 and NGC 4298. They are two galaxies right next to each other. So it's kind of a 2-for-1 deal. And let's hop over to the cameras and see what we can see on these two galaxies. Now, while the camera is actually taking the pictures there, NGC 4302 is 55 million light years away from the Earth and 82,000 light years in diameter. And if you look close in here, you can actually just start to see them. And right there in the center, there is a faint haze, and this is actually very similar to what we see in telescopes. You'll hear a lot of people saying faint fuzzy, highly technical term, by the way. But yeah, we're just looking for little fuzzballs, essentially. The cameras that we're actually using tonight make it a lot easier, and as you can see, as the camera pulls up more and more exposure times, the galaxies become easier to see. So the ones we're actually looking at here is NGC 4302, which is right here. And then we have NGC 4298, which is up here. So let's break that down a little bit. NGC 4302 is 55 million light years away from the Earth and 82,000 light years edge to edge. Its nearby companion, NGC 4298, is 55 million light years away and 40,000 light years in diameter. Both of these were actually discovered by William Herschel in 1784. The galaxies are both part of the Virgo cluster. And NGC 4302 is an edge-on spiral. You can see it almost looks like we're looking down the edge of a CD. That's what we call an edge-on spiral. Whereas NGC 4298 is a flocculent spiral. And what that means is it is a spiral galaxy, but rather than having real detailed spiral arms, it's more patchy with dust clouds and such kind of span through the actual arms of the galaxy rather than nice organized bands of dust in there. And that's called a flocculent galaxy, spiral galaxy. Now, it is believed that the two galaxies are interacting with one another through a process called tidal bridge. And this actually means that some of the gravitation between the two galaxies is kind of interlocked, causing some disturbances in either galaxy between the stars. And currently it's projected that these two are actually about 36,000 light years apart from one another. But those measurements can actually range depending on different information that you're looking for and different observations. But as you can see, as we sit on this target longer, we're actually able to start to resolve some of those galaxies. There's some other faint ones in the field there, but this particular one right here, this edge-on, that is NGC 4302. And then the other spiral galaxy that we have up here is NGC 4298. And this is in the constellation of Coma Berenices. And this is also part of the Virgo supercluster of galaxies. So a really kind of a cool 2-for-1 thing. This set of galaxies really requires darker skies and larger telescopes to see, so this wouldn't be something I would say is a good backyard target to go out and try unless you're in a very dark location. Telescopes of about 12-inch in aperture is really probably where you'd want to be. But if you've got either cameras like we're using tonight or a larger telescope in dark skies that's going to give you that punch to view into the night sky, these become easier, but they are going to be quite a bit of a challenge. But it is something cool to try and go check out if you get the chance, or come to the Grand Canyon in the future, and I'm sure one of our astronomers out there will be more than happy to show you this amazing pair of galaxies. So once again, NGC 4302 right down here, and its companion NGC 4298 right above that. So we're gonna stop our cameras here and move on to our next set of targets. But the next one is actually a very cool galaxy. It has a unique name for itself. So we're gonna slew over there. And while the telescope's doing that, let me show you where we're at. We're actually not too far from the current set of galaxies that we're already on. So as you can see, we've actually moved up further into the constellation of Coma Berenices, the galaxy known as M or Messier 64, also known as the Black Eye Galaxy. And when you see the image come up on the screen, you'll understand why it actually has the name Black Eye Galaxy. So let's get that started and take a good look at this galaxy and show you why exactly it gets the name that it does get. Now, this galaxy was actually discovered by Edward Pigott in 1779. Charles Messier, which the M is actually designated for because its catalog number is M64. Charles Messier, who was a comet hunter, was actually did not catalog this until 1780. So Edward Pigott was the first one to discover the Black Eye Galaxy, but Charles Messier did not catalog it in his catalog as M64. until 1780, a year after it was discovered. Now, as you can see here, right in the middle, this is the Black Eye Galaxy, and it, strangely enough, looks like a black eye, doesn't it? Something kind of neat. Now, the reason why it's called the Black Eye Galaxy is because it has a dark region of dust which absorbs light. This gives it that dark appearance just off the center of the nucleus of the galaxy there. And that's why it gives it kind of that black eye look, like it looks like it got, hit in the face there and given that look of a black eye. Now, M64 is actually a very interesting galaxy because the inner portion of the galaxy is actually spinning in the opposite direction as the outer portion is. And it's believed that this galaxy actually absorbed in a merger, a satellite galaxy, and is causing that spinning to happen in alternate directions. And it's, like I said, this is located in the constellation Coma Berenices, and it's actually fairly close. This is about 17 million light years away from the Earth and spans about 44,000 light years in diameter. And that is the Black Eye Galaxy, or M64, in the constellation of Coma Berenices. This is also visible. You can actually catch this in brighter skies. You don't need the darkest skies to see this visually in a telescope. Dark skies always help. They improve contrast and they allow you to see everything that the telescope is capable of seeing. But for the most part, this galaxy can be seen from light polluted locations, probably using an 8-inch telescope or bigger. But if you have the ability to get to dark skies and actually get a view of this, even in larger telescopes, you can start to see more detail and get that really nice black eye appearance from that galaxy. So again, this is M, or Messier 64, the Black Eye Galaxy. And with that, we're going to actually wrap this target, and we're going to move over to probably one of the most popular galaxies this time of year. And it's one of my personal favorites as well. And this is actually a very popular target at Grand Canyon. So if you ever have the chance to join us up at the Star Party out there on the South Rim, this particular galaxy is looked at quite often, and from the dark skies up at the canyon, it is stunning. And this is known as the Whirlpool Galaxy, and this is in the constellation of Canis Venactices, which is just below the arc in the Big Dipper handle. And and so it's just below this star, Alkaid, in the constellation of Ursa Major, or the handle of the Big Dipper is where this is below. So again, we are looking at M51, or the Whirlpool Galaxy, which is located just under the bright star Alkaid. So let's flip out of our star chart here and pop on the camera. And this is actually a really great galaxy. It's amazing to see. It does not take much to see up in a dark sky site like Grand Canyon. You can glimpse it from light polluted locations, but ultimately, dark skies are going to give you that stunning detail that this galaxy can show. And we'll see it up right here. So right here is M51, or the Whirlpool Galaxy, and we'll get a really nice shot of it here in just a second as things build up. Let's actually increase this a bit just to pull out some detail. So while we're waiting for the camera to kind of accumulate its data, M51 is 23 million light years away and 76,000 light years in diameter, so it's fairly good size. This was originally discovered by Charles Messier in 1773. It wasn't until 1781 that the companion galaxy right here, NGC 5195, was discovered by Charles Messier's assistant Pierre Machon, and he was able to discover the companion galaxy. Now, this is actually a set of interacting galaxies. And what that means is the two are actually, or have already, intersected with one another. There we go. You can see the detail in the arms are coming out a lot more now. Kind of looks like a snail, is what I think. Here's the snail head, and then here's kind of his shell, and he's kind of inching through space. So that's just kind of a fun thing for me personally. But you can start to see those beautiful spiral arms, and this is very similar to what it would look like in a telescope. A little darker background, which it'll get better as more images accumulate, but that is something that we can easily see from a dark sky location, and fairly small. I've seen this in a binocular, 50 millimeter binoculars. It just looks like a fuzz, but if you want to get that beautiful structure in the arms of the galaxy, then you need larger telescopes to see that, probably starting at about 4 to 6 inches. And then if you go larger, the detail just gets more spectacular. Now, like I said earlier, M51 and its companion galaxy, NGC 5195, are interacting. And you can actually see that bridge right there. And this galaxy is actually slightly behind the main spiral galaxy that we see here. And because of that, they've already passed each other. They're actually splitting apart from each other slowly. But this is a background, slightly in the background, where the main spiral galaxy is more foreground. Now, this is what we like to call a face-on spiral galaxy. So you can see how it gets its name. It has these really stunning spiral arms, and in those spiral arms it has what are called H2 regions, which are clouds of hydrogen gas that are condensing down and are making new stars. They're stellar nurseries. And in some of the more advanced astrophotography images, you can see kind of these bright pink sections in the arms. That, of course, is those H2 regions. But even in a telescope, you can start to bring out some of the fainter and structured detail found in this galaxy. And this is fairly easy to see even in smaller telescopes, especially in a dark sky site. So very, very popular target this time of year, and something that you can actually try with your telescopes at home. But if you ever have a chance to get to a dark sky location or join us at a future Grand Canyon Star Party, we'll be happy to show you this. But this is a great image of this particular target for this evening. So the M51, the Whirlpool Galaxy. And again, this is 23 million light years away, 76,000 light years in diameter in the constellation of Canis Venactices, just below the arm of the Big Dipper. So if you ever get a chance to go out, definitely check this one out. It's well worth it. So we're going to stop this run right now because we're moving on to our next target. We have about a dozen targets for this evening. Most of them are galaxies because in the early part of the evening, generally up at Grand Canyon, we still have some of the spring constellations like Leo, Virgo, Canis Venactices, Ursa Major. All of that is generally visible in the early evening before a lot of the Milky Way rises. And then within those, there is a lot of galaxies to be seen. So tonight we're working on mostly galaxies. And then the next time you see me, we'll be checking out some other summertime targets. And that'll be in the next webcast video with me. So let's stop our exposures here. We're going to flip our target and head over to another galaxy. And we do have some other objects in here that I think you guys will find really, really cool. But like I said, most of these are going to be galaxies tonight. So let me get the telescope over there. This particular galaxy that we're going to be looking at now is in the constellation Ursa Major. and I will show you guys where this actually sits. This one's called M108 or Messier 108, and this is in the lower portion of the bowl of the Big Dipper, right by the bright star Merak, or Merak. Sorry, Merak is a bright star in the constellation of Andromeda, which is not up right now. So Merak is the close one that we're looking at there, but the particular object that we're looking at is called M108, and it is a galaxy located right there in the lower portion of the bowl of the Big Dipper. So let's get our planetarium down there real quick. The telescope's already on the target, so let's start taking a look at that. Let me switch our exposures here, and let's get started. So M108, or Messier 108, is 32 million light years away from the Earth and 32,000 light years in diameter. It was discovered by Pierre Marchand, which was, like I said, Charles Messier's associate and assistant, found in 1782. But what was interesting about this one, for whatever reason, it wasn't actually added to the Messier catalog until the 1950s. So several centuries actually went by before we actually were able to get this particular galaxy actually cataloged on the Messier catalog. So right there, right in the middle there, this is M108. This is called a barred spiral galaxy. And this one's actually almost edge-on, so it doesn't actually give us that view like we saw with the Whirlpool. The Whirlpool was a face-on spiral, but what a barred spiral is it looks a lot like how the Whirlpool did, but instead of having those nice, even whirling arms, it has like a central bar that kind of looks like this, and then the arms kind of split off that bar. So this is actually what M108 is, but because it's viewed at kind of an angle like this, it's nearly edge-on from our perspective here on Earth. This belongs to the Ursa Major cluster of galaxies, which is actually a portion of the Virgo supercluster of galaxies, which has hundreds of galaxies in it, including the Milky Way and Andromeda are also part of the Virgo cluster. But this particular area is part of the Virgo supercluster, but it's a segmented piece of that cluster called the Ursa Major cluster of galaxies. Now, like most galaxies, this one's also moving away from us here on Earth. And this one's actually not nearly as fast as some of the other galaxies, but it's still going about 480 miles per second away from us at the moment. So this is M108 or Messier 108, 32 million light years away and 32,000 light years in diameter. Now, what's actually kind of interesting about this galaxy is that it sits right next to another object, and that object is on our list, and we're just gonna fling right over to that real quick. And this is going to change up our galaxy run here for a minute. And we are now on this next target. So let me get our camera going here and see what we can actually see with this one. So this is not going to be a galaxy. This is one of the few things that are not galaxies tonight. This is M97, the Owl Nebula. And the Owl Nebula is right next door to M108. Odds are you're probably going to see both of them in the same field of view. Now, this is what's known as a planetary nebula. A planetary nebula is a star that used to be about the size of our sun. And eventually, it extinguished a lot of the gas and material. Its fuel, it burned out. And at that point, what happens to a star is it sheds off its outer layers into space. I don't know if I have my fancy little ball here. I don't. Show you anyway. what this actually happens is the star dies, shedding off its outer layers into space, making this little bubble. And that's what we're actually able to see, and that's called a planetary nebula. Now, this was also discovered by Pierre Montchan. Probably butchered that name too much, but this was discovered in 1782, or 1781, about a year before the nearby M108 galaxy. Now, what's cool about planetary nebulas is that we're actually able to use different filters called narrowband filters to cut out a lot of the additional light that we see here to actually pull more detail out. I want to show you how that works because this particular telescope we're using tonight is actually fitted with those types of filters. Now, what we've been using right now, and you can see it right there, that is visible light. This would be what's the green filter. So the light that is passing on from the telescope to the camera is passing through a filter that filters out all the colors except for green, which is where the human eye peaks. So when you look through a telescope, it would be something very similar to this, but because we have a very high level telescope with a very sensitive camera, we're going to move a different filter in there called a hydrogen alpha filter. Now, a hydrogen alpha filter isolates a very, very thin line of light in the red part of the spectrum. And with that, so do many nebulas also emit light. So this filter is actually aimed to highlight that light and pass it through the telescope while blocking all other forms of light. And what you can see here is it's much more contrast, and it blocks out a lot of that extra light, and we can start to see more of the details in this nebula. The one issue that we have with filters like this, though, is because they're very precise on what type of light passes through them, they filter out a lot of additional light. So there's not a lot of light actually reaching the camera. So this is where those long exposures really, really set in. But you can just start to see it there, a little ghostly bubble. That is the planetary nebula, and planetary nebulas get their name because they do look like a planet, because they're kind of round and spherical, and they appear kind of bright in the telescope. Some of them do. Some of them are really obscure and faint. And in the next webcast with me, we're actually going to be looking at some of the brighter planetary nebulas that are up in the coming summer months. And they will be very, very easy to see in detail like this. Now, M97 here is actually 2,000 light years away from the Earth and about just under a light year in diameter. We're going to switch filters here and actually switch to another filter just to bring out some more detail. Now, just a couple cool things about this. As a star dies, when it sheds off its outer layers, and you can see that little puff of gas floating out there, at the very core of that nebula is the leftover core of the original star, and this is known as a white dwarf. Now, you can essentially see that it's kind of like the corpse of that star. And you can see right here with this filter, it's a lot easier to see. This particular nebula emits a lot of light in the blue part of the spectrum, particularly double ionized oxygen, and that's the filter that we're using. It's called an oxygen 3 filter, and it actually allows double ionized oxygen to pass through. And because we know this and use that filter, we can actually start to see some of the detail. And you can see where it gets its name, the owl. You can see these two dark gray lobes in there, and that makes it kind of looks like an owl's face, and that's how it gets the name Owl Nebula. Now, one real cool thing about this one is it contains about 50% of the mass of the sun, this whole nebula. The central star, the white dwarf in the center of the nebula, It's about 50% of the mass of our sun, so it's smaller. But the surface temperature is about 220,000 degrees Fahrenheit. And that is the leftover white dwarf at the center of the Owl Nebula, or M97, which is in the constellation Ursa Major, distance about 2,000 light years away from the Earth, and just under a light year in diameter. So we're going to continue on with our tour. Let me stop this real quick, and we're going to flip over real quick on this, because we were talking M108. Let me zoom in here. Here's M108, and here's M97. You can see they're really close to each other. So M97 is here, and M108 is here. So those two are almost close to being one of those, 2-for-1 deals I was talking about earlier. So let me zoom out here, and I'm going to show you where our next target is. We're going to go back into some galaxies, but this is M106, and M106 is technically in the constellation of Canis Venactices, which is right over here, but it's right on that border between Canis Venactice and Ursa Major, so almost there. But we're going to get the telescope onto this target as well, so bear with me real quick, and let me make our change up here and slew on over to our next target. And here we go. So let me get the camera going here. And we're going to flip back to a more robust filter for this. We don't need those special narrowband filters for this. We are using the visual filter once again. So M106 again is in the constellation of Canis Venactices. It's 24 million light years away from the Earth, 135,000 light years in diameter. This was also discovered by Pierre Machin in 1781. And this is a spiral galaxy. You can already start to make out some of the spiral detail in there. This is a much brighter galaxy than some of the other ones that we've been viewing tonight. So the camera and the telescope make it really, really easy to pick up the detail in there. And let's zoom in just a little bit. You can actually start to see some of that spiral structure inside that galaxy. Now, M106 is really, really interesting. Most galaxies have one set, most spiral galaxies have one set of spiral arms. This one has two. As you can see here, these are the basic spiral arms, and these are generally darker blue and have a collection of star-forming regions where baby stars are essentially being created. But what's interesting about this, and if you look up the Hubble image of this galaxy, it actually has bright red spiral arms kind of jetting out from the center. And that has actually nothing to do with the galaxy itself. It has everything to do with the black hole that's in the center of this galaxy. So this actually has a black hole in the center. And what astronomers believe is these bright reddish pink spiral arms, the second set of arms in this galaxy, are actually from the black hole whipping up material and speeding it up, heating it up so it looks more red in there. And if you have a chance to go check out the Hubble Space Telescope image of that galaxy, it's really quite impressive because you can see the standard arms with the stars are being formed, but then you can see those bright, detailed red arms that are actually jetting out into and away from the center of the galaxy there. And in the center, of course, we have the black hole that's in there. And that actually brings us up to a couple targets where we're going to segue into black holes and the observation of those, because we actually can't see visually a black hole. There was an image released late last year that finally had an image of a black hole, but that was the first. And unfortunately, we just don't have the budget to have something like that here. So we're going to do the best that we can. So again, this is M106 in the constellation of Canis Venactices, 24 million light years away, 135 light years in diameter, and M106. And you can start to see some of the detailing in there a little bit more now as the exposures get longer. But if you also look close, there's some other galaxies in this image as well. So some of these star fields, you do tend to see a lot of galaxies around the main galaxy that we're looking at. So again, this is M106 right in the center here. And let me get my little square. I'm sure you can already figure out what we're actually talking about, but just to make sure we all know, M106 right there in the center is what we are checking out right now, and that is in the constellation of Canis Venactices at 24 million light years, 135,000 light years in diameter. So we're going to kick it up a notch at this point, and we're going to go really, really far away from a lot of what we've been looking at. Everything we've been looking at right now has been a couple million light years from us. This next target, we're going to go even further. Now, this next target that we're actually going to be talking about is in the constellation of Virgo, and it's right here. And this is known as 3C273, which sounds super exotic. But let me get rid of my little square here so you guys can actually see it. Oop, there we go. Right there. This is 3C273 in the constellation of Virgo. So let me flip over to the camera so we can actually see what we're talking about and get a good glimpse of what it is we're actually checking out right now. Now, 3C273 is known as a quasi-stellar radio source, or quasar. And these are some of the furthest things that we can actually see in the nighttime sky. And obviously, from what we're looking at right here, it doesn't look like there's a whole lot going on. And there's not, until we know exactly. Let me switch filters here just so we can kind of isolate it a little bit better. There's not a lot going on in here except what we're looking for. And I'm going to point that out here in just a second, and we'll check it out and start going into what exactly is a quasi-stellar radio source, or a quasar. And that'll be a lot easier to see here in a minute as the camera updates. So a quasar is basically an active galaxy nucleus. So we have a galaxy that has a black hole in it, and it needs to be active to actually have this going on. And we know that these exist because we observe the night sky with radio telescopes that actually can see radio waves. And objects like this can actually emit a lot of frequencies in the radio portion of the spectrum, which is generally out of our visible eyes. So we're actually looking right here. Now, what's interesting about this is because it's so far away, it actually tends to be more shifted towards the red part of the spectrum. So we're using our green filter right now. So if we flip over to the red filter, it actually becomes a lot easier to see. So check this out. We're going to do a longer exposure here. We're looking right here in the center. Right here where my cursor is the quasar, and this is the green filter. And once the red filter image pops up right here, it should actually be more easy to see a little bit, as you can actually see there. But we are looking a substantial amount of distance right now. This is 2.5 billion light years away, and 2.5 billion light years away from us. Now, this is basically a galaxy, and in the center of that galaxy is a active black hole that's actually feeding on material from that galaxy. So it's active, and when it's active and it's eating this material or feeding on this material, it causes the material around the black hole as it spins in to glow and really, really heat up. And when that happens, that glow becomes very bright and it looks like a star. And that is what we're actually seeing right here with this quasar. Now, just to give you an idea of how bright this would actually be, let's say we move this to about 30 light years away from us, 30 light years away from our solar system. This object would be as bright as the sun is in daylight, and that would be 30 light years away from the Earth. That would be crazy. So these are very, very bright, lots of heat, and this is actually the brightest quasar in the nighttime sky and it sits about 2.5 billion light years away. I like to call these concept objects because it's all about the concept of what you're looking at. It doesn't look like much. I know it looks like a star, but the fact that we're looking 2.5 billion years into the past is mind-boggling. So something to see. This is visible in telescopes around 10 inches in aperture or larger. It does look like a star in all of them, but if you're looking for a challenge or looking for something to impress your friends, this is in the constellation of Virgo, and that is 3C 273. Now, while we're on the subject of quasars, we're going to get another setup in here real quick, but we're going to just up our focuser here for just a second to make sure things are nice and sharp for this next one, because we really need to make sure everything is going to be as good as we can. So what we're going to do right now is just have the telescope go through a real quick focus run to get everything nice and sharp. As the telescope moves around and the temperatures fluctuate outside, your telescope focus can suffer. So this particular telescope has a motor on its focuser so it can automatically refocus. So we're going to let it go through its focus point right now. Just to wrap up, we've got about 2 objects left. So we just finished up on 3C 273. That is the brightest quasar in the nighttime sky. It's in the constellation of Virgo, 2.5 billion light years away. We did M106, which is a spiral galaxy in Canis Venactus. We did M97, or the Owl Nebula, a planetary in Ursa Major. M108, which is another spiral galaxy not far from M97. The beautiful Whirlpool Galaxy, M51. M64, the Black Eye Galaxy. NGC 4302 and 4298. The Stargate Cluster. And of course, NGC 3643 and its supernova. So that is all the objects that we've done tonight. And our next thing, we're going to continue on with quasars, and we're going to see what we can get out of them. This next one is a bit more of a challenge than 3C 273. If we can get it, it's going to be very, very cool. So let's give this a shot and see what we can get out of it, because it really does give a very, very cool aspect of what's being studied right now in the professional field. So this one's actually quite remote. So we're going to get the position of this actually plugged in real quick. So we're going to pop in the coordinates, and I've got those jotted down right here, and we're gonna fling over there real quick and see if we can see it. This is one that I haven't done in this size of a telescope yet. I've seen this done by the McDonald Observatory in one of their live feeds, but they are using a 16-inch telescope from a really good location, and it'll be interesting to see how our little 6-inch telescope tonight handles this. So let's just get the coordinates plugged in here. There we go, and we're going to have the telescope slew right over there. This is also in Ursa Major, so we're moving from Virgo. I'll actually show you this. We're moving from Virgo right here with 3C273 to Ursa Major, so little big move there. So let's see what we can actually get out of this, and let me just double check some stuff real quick on the focuser, so make sure we're getting a nice sharp set of images real quick, and we can get our stuff looking good. That seems to be all right. This is all stuff, if you ever get into astrophotography, all stuff you have to check out and look into. So that seems to be doing okay. So let's get this going. So again, this is, I've never done this one in this telescope. Generally you need very, very dark skies and very, very good seeing conditions where they're nice and stable and it's not blurring all around. And but we'll give this one a go real quick and see what we can get. As you can see, there are some galaxies in this position as well. So let's see what I can pull out here for just a second. So this is going to be a pretty interesting test run here to see if we can get it, because we are looking at another set of quasars. Very, very distant active galaxy nucleus from a very, very far away set of galaxies. So let's see if we can see it here. See if we can get a reference real quick. Because what we're seeing is very, very faint and very, very far away. So let me see if I can pull up my reference map here. All right. So, and this is actually how we tend to locate objects by viewing anyway, is star hopping. And when you're actually looking for distant objects, this is how we tend to look for those objects, is you have an image like this or a star map, and you have to jump from one to the next, to the next, to the next. Let's see if I can find this one. Okay. Get a good detail map here. And we've got the 3 stars here. This one might be a little tough. Let me stop this real quick and see if I can find oh, let's stop this. So we were going to do a set of another quasar. This one is actually a bit more of a challenge than the previous one. So I it requires that we have a very, very detailed star chart and very calm skies. And tonight we have a little bit of breeze on telescope out there as well. So getting some of this to be really nice and sharp can be a little difficult when you have breeze moving the telescope. So let me see if I can find what we're looking for real quick, and maybe we can pull out some of those details real quick and see if the camera can pick up this very, very faint, distant object. It might just be a little bit too much. Let's see. Yeah, this one might be a little too tiny for this particular telescope. When you're shooting real faint things like what we're doing right now, you have limitations on what the telescope can actually physically pull out because of its aperture size. I've seen this done with a 16-inch telescope, but a 16-inch telescope has much more resolution than a 6-inch telescope does. So you want to be careful with observing some of these things, because it becomes a really, really large challenge when you're trying to catch some of this. So this might be something that we can approach in the next run, but that's what happens when you're doing some of this, some of these feeds, these virtual star parties, is we try to make some of these objects really, really interesting, but it can be difficult to actually acquire some of these objects because they can be such a challenge. And we're really pushing the limits on this particular telescope. So we're going to stop on this one and skip over this and go to our final object of the night. And this one is super popular. So let me show you guys where this final target is for this evening. This is in the constellation of Hercules, which at this time of year is straight overhead. And we talked about that earlier. And it's just off the keystone here. If you remember earlier when we were talking about that, you see the body of Hercules, this 4 stars right here. That's the keystone. And right in there is the cluster M13. Now, M13 is a cluster of 1 million stars, about 25,000 light years away. And what is great about this one, this is a very popular target at the Grand Canyon Star Party. There's a lot of telescopes that end up looking at this because it's such a great target. It actually looks like spilt sugar on black tablecloth, kind of like a black pile of sugar. But once it gets dark, you can actually see this naked eye as a little fuzzy, and a pair of binoculars can be very helpful. But a small telescope, really any size telescope, can catch this from a dark sky. But let's take a really close look at this with the camera, and it's a pretty spectacular view with something like this. Now, the Hercules star cluster, again, is 25,000 light years away, 135 light years in diameter, and it's what's known as a globular cluster, which is a dense ball of stars. And there is about 200 of these clusters in the Milky Way that form a halo around the core of the galaxy. There's M13 right there. So something cool right there to check out. This was discovered by Edmund Halley in 1714, and but was not cataloged until 1764 by Charles Messier. Now, as I said earlier, this is naked eye visible at dark skies like the Grand Canyon. You can actually see it as a little fuzz or diffuse looking view in there, and it's very neat to see it. Let me see if I can sharpen up the image here real quick while we're talking about M13. Now, these globular clusters, these are dense balls of stars. And with that, they actually think that some of these, particularly like the larger ones like M13, might have actually been captured galaxies that the Milky Way may have taken over in its lifetime. So that's what they think could be M13 because there's so many stars in it. Most globular clusters have a couple 100,000 stars inside of them, where M13 has about 500,000 stars inside of it, or more, depending on who you talk to. But it's not the largest globular cluster in the Milky Way. That actually goes to a cluster known as Omega Centauri, which hopefully we'll get in one of these live streams, or one of these stream videos. There we go. We sharpened up that image real quick, and let's get back to it. There we go. Much better. So, M13, naked eye visible from a dark sky location. Pair of binoculars, like a 50mm set of binoculars, works really well. But if you have a telescope, really any size telescope makes this look impressive. But it's only 25,000 light years away at this point. So here is M13, and just about 1 million stars in this cluster. And you can see some little background galaxies in there as well. These are dense balls of stars, several 100,000 stars for most of these, about 200 of these in the galaxy, forming a halo. I want to stop the exposure here real quick, but because there's a cool little detail that you can actually see with this cluster, and we call it the propeller. Now, if you look close right here, there's a dark band, one here, one here, one here, kind of 3 prongs coming out. That's called the propeller, and it's just a unique detail that you can see inside of this cluster of stars, especially if you're in a dark sky location, or if you have a telescope that can resolve the details. But yeah, this dark 3-lane detail there, that's called the propeller inside of M13. So that really wraps up this stream. Again, thank you all for joining us for this episode of the Grand Canyon Virtual Star Party. You'll see me again in my second episode, which will be coming up here soon. We're going to be checking out some more nebulas up in the nighttime sky, and I look forward to having you there. Of course, check into all of the virtual feeds that are coming off for Grand Canyon this year, and thank you all for joining us. My name is Kevin Lagore with Focus Astronomy, and I hope to see and meet you guys at a future Grand Canyon Star Party. So, without further ado, thank you very much. Have a great evening, and we hope to see you under the stars very, very soon. Take care.